screen for everything. Next, we can, before running the simulator, we need, of course, to compile the P4 code. And the target is like this. It's series pipeline.json as a make target. So it will invoke a P4C for the BMV2 architecture. And as a result, we will receive this machine readable file that can be fed into the simulator. For those who are working with that are familiar, but I will also explain the next steps. So on the left, I'm running the simulator. Let's rewind a little bit. So command is make run switch. This will start this simple switch simulator, and this is actually something that I was asking some help with because it's missing a few things like those special matches, and we have some work for the connection tracking. So future improvements will be there as well, but for now it is running a reduced set of our Dash pipeline that does not include connection tracking. So after we run our simulation, it is ready to receive packets. And next step would be to configure some rules into that software switch. So we basically log into this Docker. So remember that the simulator is running in a Docker. There is a command to log into that Docker. It's make bash. It will open a CLI where we can run the simulator CLI. So the command for that would be simple switch CLI. As you can see in here, and now it's ready to receive a configuration. And this is actually the next step that I'm working on right now. And I plan on showing you the update in the next couple of weeks, which instead of using the P4 runtime native tools for programming the switch, we will actually generate a SAI library that is compatible with this software simulator, and we can use our common SAI to actually program the software switch as well. But for this demo, we have a native tool being used. So we just copy this configuration. So if you look at it, it's if you were familiarized with the P4 implementation of Dash, this is just adding entries to a variety of tables. Like for example, direction lookup, ENI lookups, ENI to VNI mappings, CA to PA mappings, routing, some prefix in here, and all of the resulting mappings like what's the PA, what's the overlay DMAC, which VNI should we use, and so on. So this is kind of less intuitive right now, but when we will have SAI to P4 runtime mapping, it will be much clearer because it will be exactly what Sonic is going to use. But for now, we just copy that configuration. We just pass it to the CLI. You see that it configures the simulation itself. And we are moving to the next step. We will run a couple of packets. So now I have.
Again, sorry to interrupt. Just quick question.
Yeah.
Are we running the table add is not a P4 runtime API, right? It's just a low-level abstraction.
Table add, it's a CLI wrapper for the CLI P4 runtime client for this for the simulator.
But our goal is to run the SAI-Dash API, which underneath all P4 runtime or something else. Okay, thanks.
Right. Yeah. So we're just using Scapy as an example. So here we're building our packet. This is a VXLAN packet that that is destined to our appliance. So the underlay destination is the appliance IP, and here are the customer addresses 111, 112. So as I said, no connection tracking for now. It's just one packet processing. So we are only verifying the VNet routing and a mapping parts, not the policies. But we can send this packet, so we'll run TCP dump. Basically, the software switch right now has two interfaces. It's completely flexible, but just for the manual use, I created by default two interfaces. One is ingress, another one is egress. We can do more realistic models as well. And on one, it's coming in. On the other, it's going out. So let's see. So here is our ingress on the middle terminal. And it's got the, as you can see, source IP, destination IP, 222.1.2.2 and so on, what we just put into the Scapy. And here all the mappings are done. We have our VNet VNI set, we have our overlay DMAC set, we have our CA to PA mappings done, like this 1112 address maps to the underlay 2222. Yeah, so this is one example. Probably there is another packet. Let's see. Yeah, so we're just changing this time CA to a different value, which will result in a different mapping. So this time we'll get a, so before it was a destination VNI, if I'm not mistaken. This time rules are saying, please use the source VNI. And yeah, so that's the difference, basically. So this is how to operate it. And a couple of words about the next steps. Me and a couple of Microsoft engineers will be working on bringing this simulator to the full-blown, let's say, Sonic simulator, where we can spawn the instance of a virtual switch with all of the Sonic interfaces. Plus, I'm working on SAI to P4 runtime translation, so we will have SAI API for configuring this switch. And then upon improving the P4 code itself, we will get more and more functionality from this simulator. So this is our step number one, and in a couple of weeks, I will have an update on the future progress. Yeah, that's it. So if you have any questions.
Thank you, Marian. Okay, he opened it up for questions, guys, so.
And there's some raised hands.
Okay, who is first then?
Lisa.
Lisa?
No, my previous question for Lee was already asked. Thanks. Yeah.
Okay, then the next question is Chris.
Marian, thanks a lot. This is a great project, and I did try to go through your READMEs and build the containers last week, and I posted some of my feedback in the pull request. I can't actually complete the process, and I think there was another Dash participant who had the same problem I did. So if you can go back and look at those comments, if anyone else wants to try to build these containers too, if they have success or failure, it would be nice to get some user feedback. I'd like to reproduce all this, but I ran into
great. Yeah, so there might be some difference in the environment, and it's good that you tried, so I will take a look. Let's see what's missing. Sure.
Great. Thank you. Yeah, I look forward to playing with this. It's a nice job.
Fantastic. Thank you very much. And it looks like we're running at about time. So the action items for next meeting would be for the community to go ahead and look at the simulator, look at the pull requests. Michael and I will post drawings as soon as we make a few more refinements. We'll put in the request to do that. Liwa, Gerald, any closing thoughts for this week?
I'm sorry, Christina. I still had a question for Marian.
Oh, okay, go ahead.
I don't know, maybe I missed the part, but I had understood that you would have demonstrated also the compiler that generates the SCI API. Did I miss it, or did you not present it?
Oh, no, I did not include that. So let me do that next time, along with the generation of the library itself, because my next target is SCI to P4 runtime mapping, so we can use SCI to program that. So I will do it next time.
Oh, got it. Thank you very much.
So in 2 weeks, Marian?
Yeah.
Okay, sounds good.
And another question I have very quickly. So this emulator does not support those extensions that we spoke about. So how do you deal with it? You simply compile without that piece of code, like avoid compiling that part of the code, or somehow you just skip it, or the compiler?
Yeah, so if you notice, those are under the define, so all the connection tracking is not compiled.
Right, so okay, I couldn't see, so right now you undefined those. Great, thank you very much.
Christina, I have a non-technical question for you. I couldn't attend the last 2 meetings and I was trying to get the recordings. Looks like they're restricted.
Yeah, just email me. Send me an email, krisny@microsoft.com.
Got it. Thanks.
Yep, I'll take care of it. Right. Gerald, Liwa, any closing thoughts? And
I just want to say that I really appreciate, and we're looking forward to really hear all the feedbacks, right, good or bad. I think John is having on the chat. I think there's a few very good questions, and we always try to learn from the community, and so your feedbacks, criticism, support, or like or dislike. So please, let's work together on this, right?
Yeah.
All right.
Christina, can I just have
sorry.
a couple minutes, the last couple minutes?
Yeah.
Oh.
And I think someone else mentioned something too.
Oh, I just wanted to share my screen briefly, and I won't spend much time on this, but there are a couple of pull requests that I've worked on. One is with this diagram and a description of it. This is the P4 variations. This is the one that Marian is working on that represents it, and this is the one that Intel's working on. And I've talked back channel to vet these diagrams, so I think they're fairly representative, and there's a description of all this. So people could take a look at this pull request at some point. I'd like to get it accepted. And then there's another pull request that talks about what I call dash testing maturity stages. And I'm just trying to lay the groundwork for how the data plane can be tested bottom up in various stages, and also how Sonnet can be tested top down. And I've just put some thoughts together. If people could take a look at that, so lay some groundwork. I don't expect to discuss it today. There's a lot here. That would be appreciated.
So some comments would be appreciated, and then we could discuss it next week.
Or the next opportunity. Might take a while for people to digest. Thanks.
Okay, thanks, Chris. Anyone else?
Christina, one last question for Liwa. So for the smartwatch, all the use case and the packet transformer will be applicable to smartwatch as well?
Yeah, that's what we believe, right? Because it's just all packet transformations, right? And smart switch might basically having a hybrid of pipeline, right? The two pipeline might be a little bit different in between the switch ASIC and the DPU, but the packet transformation itself by definition is independent of the hardware.
Yes. Yeah. Another question is the intelligence of where you place, like you mentioned earlier, depends on the resource of the switch versus the DPU. You may place your connection or whatever the tunnel programming differently. So the intelligence will be an OR agent strictly and no else. Is that the right understanding?
Yeah, I think that that's what we're thinking. Yes, right. So I think the earlier the gateway example we worked out. That's how we structured it.
Okay, got it. Thank you. Yeah.
Okay, thanks everyone. I will release you to your 10 o'clock meeting. I appreciate your time and I will see you next week. Please reach out to me specifically if you need to access recordings, etc. Just give me an email. Thank you.
Thanks a lot.
Okay,
Thanks.
appreciate
Thank
y'all.
you.
Okay, bye-bye.
Thank you. Bye-bye.